This example talks about solving an equation graphically as opposed to solving it algebraically. When we talk about graphical method, we have a graph for an equation like this, and then we use this graph to directly find an answer instead of calculating it directly. If we have a graph for our equation readily available, then it might actually save us a lot of time. So for this example, the length of a rectangle is x, and the width is less than 2 times the length by 19. We want to find the area in terms of x. This is easy. The width of the rectangle would be 2x minus 19 cm. And so the area of a rectangle would be the length times width. And so this would be the answer. Now for part 2, if the area is 90, show that this is true. Because the area of a rectangle is 90 cm square. And so using part A, this equals to 90. And so this is true. Now the most important part is actually part B. We are going to find the roots of this. If we're going to solve this algebraically, from last year we know that we used the quadratic formula, right? But now we are doing this graphically because we are using this graph. Now in order to do this, the key is to match the equation of the question with the equation of the graph. That is this one. So we have to go from here to here. So I start out with this equation from the question. I need to do something on both sides in order to arrive at the equation on the graph. In other words, I add 140 on both sides. Now this is saying when y equals to this, at the same time, y also equals to 140. So we have to put the two equations together. In other words, I'm drawing this line right here. And then we want to find the intersections, which are these 2 points. And we find the corresponding x values. And so the answers would be negative 3.5 and 13.0, correct to nearest 0.5. Now part C brings us back to the problem of the rectangle. With all these restrictions, what is the length of the rectangle? We know that x being the length must be greater than 0. And the width must also be greater than 0, right? And the x must be greater than 19 over 2. Now consider the area must be 90, and there's only 2 possible x. And with this restriction, then we can conclude that only this would be the answer for x. So when we put everything together, the length must be 13.0 cm. Now to better understand the key to this topic, let's try one more example. This figure is for this equation, and we're going to use this graph to solve this. Now just a friendly reminder, if we're going to solve this algebraically, we have to solve this, and because it's cubic, we have to consider using factor theorem, but it may not work if the roots are not rational numbers. But no worries, we are going to do this graphically. But the question is, how do I go from here to here? Okay, but if you look at the coefficients, you see that this is 2 times this. The coefficient of x squared is 2 times this coefficient. Likewise, this term is also 2 times this, right? So the coefficients may give us a clue here. So I start out by taking out the 2 here. And now this is almost the same as this, except with the 3. So I add 3 on both sides. This would be exactly the same as this here. So now we're going to draw this line. So I set this to be y, and then I add this line here, y equals to negative 1 over 2. And so from the graph, the roots would be the intersections here are these 3 numbers, correct to 1 dp because 1 unit here would be 0.1.